everyone hear me? Can you see the slideshow? Okay, good. Let's begin. You want to know what really scares me? Not understanding a single thing that was said in the lecture. Am I following along this Zoom call right now? Absolutely not. It's not the professor's fault, just that these concepts are really hard to learn, and many students have been in the same place before. So without further ado, I will teach you about chromatography. And what is this scary music? Can we cut that out? Thanks. Let's go. So what is chromatography? Chromatography is the mechanism or method which separates a mixture into its separate components to allow quantitative and qualitative analysis. Here's an analogy to help explain that. Here are two students in the same class with the same project that have been assigned by the same prof. Both of these students have the same amount of time to finish this project and have started at exactly the same time. The only difference between these two students is that one of them gets heavily distracted by their phone and the other student continuously works on the project until completion. As you can see, the student who gets distracted by their phone progresses much slower compared to the motivated student and begins to lag behind in completion. These two students who were originally in identical positions in the beginning have now been separated in terms of completion of their projects. This is a very simple analogy on how chromatography works. So chromatography consists of a mobile phase, which is the solvent that passes through the column, which can either be a liquid or a gas, and a stationary phase, which stays in one place within the column, allowing for the separation within a mixture of molecules. From our previous example, we can say that the cell phone acted as the stationary phase, attracting the student and reducing their progress in the project compared to the other student who rapidly finished. We could also consider that the progress within the project is acting as the mobile phase, keeping the students motivated and making them work. There are many different types of chromatography, such as absorption, partition, ion exchange, and molecular exclusion chromatographies. All of these types, however, all follow the same concept in which it relies on the attraction or size exclusion of the molecules within the mobile phase with the stationary phase to separate the mixture and allow some molecules to make faster progress compared to others. As the analyte flows through the column, it will begin to show separate bands of the separated molecules from the mixture. These bands in the column are what produce the peaks on chromatograms. Ultimately, thinner bands result in sharper peaks, allowing us to be more confident in the detection of various molecules. So there are multiple factors that lead to band broadening. One of them is longitudinal diffusion, and here's an analogy to help explain that. So we have a gym class that are going for different runs. The first task is to run a 100-meter dash. Since the distance for the 100-meter dash is pretty short, by the end of the race, the group all finish relatively close to one another. Their next task is to run 5 kilometers. Since this distance is quite far, the group who were close during the 100-meter dash begin to have a larger variance in time of finishing and produce a wider band, meaning that there is band broadening. The faster the linear flow, meaning the less time that is spent in the column, will result in less diffusional broadening. So this means that the less time spent in the column will result in a tighter pack when finishing, and when the time spent in the column is longer, there is a wider spread in finishing times between the molecules in the same group. Another factor that results in band broadening is the effect of multiple paths. Here's another analogy to help explain this concept. So let's say that we have two different mazes. We have one really complex maze and one really simple maze. With the complex maze, there are multiple paths or wrong turns that you can make before exiting the maze. These wrong turns increase the time that you spend within the maze. For the simple maze, there are a little to a few paths or wrong turns that you can make before exiting. If we put a group together and ask them to complete both mazes, we would expect that the time it takes to complete the complex one would have a larger spread in finishing times within the group compared to the simple one, as they would all complete it roughly around the same time. This multiple path factor can be applied to band broadening by the variations of paths within the column. So a column with multiple paths will result in a broader peak and have lower resolution. But a column with fewer paths will result in the group of molecules staying relatively close to each other, producing a sharp, narrow peak. Thank you guys so much for watching my video. I hope you really enjoyed it. Make sure to like and subscribe and check out my channel for more videos. Make sure to always watch the Zoom calls. See you later.